Okay, so here we're going to start with our exponential functions. And what we're going to see here is that this is going to tie in with everything we were doing about compositions and inverses, as in we need to talk about exponential functions so we can talk about the inverse exponential function known as a logarithm. So your exponential functions are going to be of the form fx is going to be equal to a of x, where a is a real number, or sorry, x is a real number, so is a. So what's important here, what makes it an exponential function, is now that x is the exponent. So this is not something we really have seen before. We've seen x's that are part of a term that have a coefficient, and this is a little different. Our exponent is going to be the x. Like I said, x is a real number. We're going to do this in real numbers. A, your base, has to be greater than 0. So meaning it has to be positive and it cannot be 1. So if it was 1, we just get 1 to the x, and it doesn't matter what power x is. We're just going to keep getting 1 over and over and over again. So we're just getting a horizontal line. So it's not very exciting. So that one we throw out as an exponential function. We need to have a base that is positive in order to avoid complex numbers, because let's say our base was like -4, and then x is going along, x is 1, maybe 3, and then you have like 4 or 2 or something like that. What we're the problem with that is that we're trying to avoid what will be negative roots. So roots and exponents are connected to each other. So if I had done a exponent of like 1/2, that's the same thing as taking a square root. So we're trying to avoid ending up with complex numbers, because we do that, we end up with something really strange looking. So like I said, we're just going to make sure that a can't produce complex numbers, and that the a has to not be 1, because then we just get something that's just a straight line. So examples of exponential functions would be like 2 to the x, 1/2 to the x, 3.57 to the x, just as long as it's positive and it's not 1. So when we graph an exponential function, we're going to compute some values and list the results in the table. So starting points that are usually good ones, so you get kind of used to the shifts and everything, are like -1, 0, and 1. We're going to plot the points and connect them with a smooth curve. So one of the things we're going to look for here is kind of like rational functions had these asymptotes we had to watch out for, because we had a curve, we just didn't know what the curve was doing unless we knew where the asymptotes were. We're going to have a similar thing here, that your exponential functions have an asymptote. And we have just concern about how quickly it rises. So we want to start with the exponential function f of x is equal to 2 to the x. So this is your list of points here. I'm going to do this in Desmos to kind of quickly show you how this is going to work, and do a little explanation as well. So you'll notice over here, here's the function and here's the table of values. So we see right there to the x. So what we notice here, where we are some of these values and ran a little bigger here. I'm going to talk about how we know what some of these values are going to be. Just a little bit of a kind of quick review on some things with exponents. So we're going to have x, and then y is supposed to be 2 to the x. Right, and these were our x values. So what you see here is I put in -3, that 0.125. Well, that's just 1/8. And then for -2, that was 1/4 is what we're seeing. For -1, we're getting 1/2. For 0, we're getting 1. For 1, we're getting 2. For 2, we're getting 4. And for 3, we're getting 8. So like I said, kind of some reminders here. If I have 2 to the power of 0, that's going to be 1, because anything to the power of 0 gives us 1, even 0 to the power of 0. So this one is always going to be 1 for us. The rest of it, we got 2 to the power of 1, meaning I only get 2 once. So I get 2. 2 to the power of 2, that means I'm squaring 2. That's going to be 4. 2 to the power of 3, that means I have 2 times 2 times 2. That ends up being 8. So what we notice right here is that everything is doubling. It's based on that base, because that base is 2. What happens if we double? We go to 1 to 2 to 4 to 8. So next would be 16, 32, 64, 128. I'm trying to remember, 128, and then 256. And you keep going like that. So everything keeps doubling. So what you see is it starts to grow really, really fast. So you can see that part right here. Oops, my 3 is missing. There we go. These points right here, as you see, we start to grow really, really fast, and we start to curve up and get really steep. Let's talk about those negative powers. So when we have these negative powers like we do here, what this is this is 2 to the negative 1. So you may remember something about reciprocals. So if you have a negative power, what happens is that we just do a reciprocal of that 2. So 2's reciprocal is just 1/2. When we do the reciprocal, that turns that power from a negative to a positive. So really, when we say 2 to the 1, negative 1, we just really mean 1/2. If I say 2 to the negative 2, it's the same idea. It's just 2 to the negative 2. So I need the reciprocal to turn that power into a positive. This is 1 over 2. And this is 1 over 2 times 1 over 2, 1/2. 2 to the negative 3 is just that 2 we're going to do a reciprocal of 1/2. So that power changes from negative 3 to 3. 1/2 times 1/2 times 1/2 is 1. So as you see, these values here, they're not necessarily doubling, they're getting smaller by 1/2. So when we're using powers that are like 0 or greater, or sorry, anything that's actually positive, we see like this doubling effect. When we have powers that are negative, then we have this halving effect as we get smaller and smaller. But notice, because we're doing that halving, we're just going to keep going back to 1/16, 1/32, 1/64, 1/128. We keep getting smaller and smaller and smaller, but we're not hitting 0. So what we see here is that we have a horizontal asymptote at y equals 0, or you can say the x-axis. So that's generally sort of like your baseline. If you just have like 2 to the x, 3 to the x, 1/2 to the x, you're going to have that horizontal asymptote at y equals 0. So once again, this is your 2 to the x, looks like this. As x increases, y increases without bound. One of the things this means is that this is going to stay what we call an increasing function. As x decreases, y decreases, getting closer and closer to 0, meaning we have an asymptote. Okay. So next what we're going to do is we're going to look at 1/2 x. So we have these two sets of points together. So once again, I'm going to do this over in Desmos. Okay. So you may notice that this looks kind of the same, except now everything's declining. Let me make my little box again. So we have x, and just as a reminder, when we had 2 to the x, -3 gave me 1/8, -2 gave me 1/4, -1 gave me 1/2, 0 gave me 1, 2 gave me 2, oops, forgot 1, 1 gives me 2, 2 gives me 4, and 3 gave me 8. Well, this is going to be a little different because now I have 1/2 of x, or 1/2 to the power of x. So if you go back to kind of what I said about reciprocals earlier, that if I have 1/2 to x, if I do the reciprocal and I get 2, that power changes to a negative now. So this can also be rewritten as 2 to the negative x. So that's another way to think about it. So if that is the case, then what we have here is that if I put 2 into the negative x, but I'm putting in a -3, that just turns into 2 to the third, so we get 8. If I'm doing this as 2 to the negative x, but now I put in a power of -2, that -2 gets reflected to a positive, and we get 2 to the 2, which is 4. So if you keep on continuing this pattern, then this is just going to be 2, and then this is going to be 0. This, if I put in 1, it's going to be 2 to the -1, so this will be 1/2. If I put in 2, this is going to be 2 to the -2. This is going to be 1/4, and then this will be 1/8. So what we're seeing here is everything's kind of, it's reflecting. To make this a little more obvious, let me put back the first function. So this was 2 to the x, and this is your 1/2 to the x. What we see happens here is that we're getting that reflection. So let me turn on my points over here. So this point that we originally had over here at 3/8 now becomes -3. So this is just a reflection over your y-axis. So that means that my x's change from positives to negatives and negatives to positives. This point here I had at 2, 4, now I reflect over here to -4. This point I had here at -2 and 1/4 now reflects here at +2 and 1/4. So when you do 1/2 x, it's just really the reflection of 2 of x. And the same thing would happen if this was, say, 3, and then this is 1/3. You're getting a reflection again. So here we have a set of points over here where all our bases. So we talk about the base B. B, in this case here on this side, we see that they're all going to be values that are less than 1. They're still positive and greater than 0. Over here, when we look at these bases, we got 4, 2.5, 1.8. All of these bases are everything that's just greater than 0. So when I have a base between 0 and 1, like we have here, what happens is that we are going to have a decreasing function. Both of them are still going to have a horizontal asymptote. In all these cases, horizontal asymptote. At y equals 0. But what's important here is that when my base is between 0 and 1, you're getting decreasing exponential functions. When my base is going to be greater than 1, then I have increasing exponential functions. You also may notice here that as my bases get larger, my graph kind of flattens out on this side, but over here, kind of have an opposite thing happening. As my bases get larger, the graph gets steeper. So we're gonna just practice some graphing. What we're gonna have here is some shifts going on. Let me make this just a tad bigger. There, we don't need to see exact example. So my function is gonna be y is equal to 2x minus 2. So when I want my y, that means I just have 2, and then x is -1 minus 2. So this is 2 to the -3rd. So we saw already that 2 to the -3rd is just 1/8. Here we have 2 to the 0 minus 2. So that's 2 to the -2, which we saw before is just 1/4. We have 2, 1 minus 2 now because I'm just replacing my x with 1. This is 2 to the -1, which we saw is just 1/2. Now if we have x is 2, that means 2 to the power of 2 minus 2, which is 2 to the 0, which is 1. If I have 2, 3 minus 2, the power of 3 minus 2, that's just 2 to the power of 1. That leaves me with 2. We have 2, and my exponent is, or my x is 4, so that's 2, 4 minus 2. That's 2 squared, so that is 4. And then my last one is 2, 5 minus 2, which is 2 to the 3rd power, and this is going to be 8. So when we graph this, we have -1, about an 1/8 here. Then at 0, we're at about a 1/4. At 1, we're at about 1/2. At 2, we're finally at 1. We hit 3, we're at 2. 4 is going to be 4. And 5 is going to be 8. And once again, we know we got this horizontal asymptote along the x-axis. So this looks just about like what we had before, but if you remember before when I had x squared, well, I had a point at 0, 1. Now I have a point at 2, 1. So this point right here got shifted over to the right by 2 points. So this is just 2 to the x, but shifted 2 points to the right, because we were adding directly or adding subtracting directly onto that x, so we get those horizontal shifts. Okay, so you have a worksheet number 8. Your problem is going to be this one here. So if you wanted, you can rewrite it as y is equal to 5 minus 1/2 x. So this case, what you're going to see when you graph this is that there's going to be a shift because of that +5 out front. Also, because there's a negative in front of that 1/2 x, you're going to get a kind of a reflection there as well. So just be prepared for that. So it's not going to quite look like the other graphs we did. But like I said, just plug in those points, your x's, find your y's, and then graph this. Okay, so for number 8, if you got the points, you should end up with, if you use this, so 3, -3, 1, 3, 4, 4.5, and 4.75. So what we have here is at -3, we have a point. -2, 1, we have a point. -1, 3, we have a point. 0, 4, we have a point. 1 and 4.5, and then 2 and 4.75, so about a quarter. So remember, we have to think where there's an asymptote. So because this 5 is added on, it's shifting everything up. So really, like here at 5 is a horizontal asymptote. We got a horizontal asymptote. Okay, yeah, there we go. Asymptote at y equals 5. So just remember, we know it has an asymptotic behavior. All right, this is gonna be a little hard to do on here. And it's hard to draw these lines on this pad. So what we see is, normally we'd see something look like this or something that looked like this. So what we have is that because we have this 1/2, it reflected this way. And then because we have this negative, it reflects like this. So it's just coming up underneath to that asymptote.